Hi, here to do the notes on Chapter 9, Section 5, Common Logarithms. In the book, this actually comes before the last section that I did, Chapter 9, Section 7, which is logs to bases other than 10. So I'd encourage you to check those notes out before this. It'll help make this make more sense. But I want to start out with just 3 examples and see if we can figure out what's going on with these common logarithms. And get my calculator back a sec. So first thing, your log key, it's over by the 7. So I just want to kind of punch these in. You could copy them down, you can not copy them down, but trying to figure out exactly what's happening here. So first one, if I do log of 10,000 and hit enter, I get a 4. And maybe I'll quick do the next one a second. So if I do log of my square root of 10, so square root of 10, and then hit enter, I get 0.5. So I'm going to pause and write those answers down. So log of 10,000 is 4, log of square root of 10 is 0.5, or maybe give you this hint, that's 1/2. So I'm hoping that you can kind of look at that and see, hey, I see kind of what's going on, especially in light of the notes in section 7. And if you can, you'll see then that maybe this here would be 6 for an answer. And if you would punch that into a calculator, you'd find out, yes, the answer actually is 6. And what a common logarithm is, we talked about logarithms in section 7, but a common logarithm is going to be base 10. And whenever you have a common logarithm or a logarithm with base 10, you can just punch it into your calculator like we did a minute ago. It's kind of like if you have, say, x. You could have an x squared, you could have an x to the third. If you have an x with no exponent written in, the assumption is just that the exponent would be 1. Same sort of thing with roots. If you could have a cubed root or a fourth root. If you have that radical sign and nothing's written in it, then you just assume it's a square root. Same sort of thing with logarithms. Logarithms, if there's no base written in, then you can just assume, you know, that the base is going to be 10 kind of by default. And if you didn't see the pattern and you're like, what in the world is he talking about? Here's kind of the rule for common logarithms. It's the same as what we had with regular logarithms, but now they'll say, if you have log of x equals y, so again, nothing's written in, so then you know the base is 10. So that means 10 to the y power equals x. So log of x equals y means 10 to the y equals x. And like I went over and over in the 9-7 notes, if you're ever trying to do a logarithm problem and you get stuck, often the first step is to take and change it to an exponent, because logarithms are new, we're really good at working with exponents. So now if I were to go over to here, this one here, you can have the same 3 types of problems as what we had before, but this here, well, I can't just punch in my calculator because it's not log of something, but I could say, well, I know the base is 10, so if you're stuck with a logarithm, change it to an exponent, 10 to the 4th, then it's going to give me 10,000. So 10,000 is the answers. So because you have 10 to the 4th, I should say equals x. That's what I was saying in the notes before, is that if you have to sit in a room and do this over and over, you just need to kind of program your brain to say this to this power equals that, this to this power equals that, this to this power equals that. That's the key to changing it from a logarithm to an exponent. Now this one here, a lot of times we get to the quiz, and people on the quiz will say, all right, change it to an exponent, so no base is written in. So it's 10 to the x power then equals 350. And in 9-8 we're going to go over kind of how this works or why this works for solving for an exponent. But you could say an exponent equals the log of the answer divided by the log of the base. And that's easier than guessing and checking like the books kind of assume you're going to do. And those terms are not really real descriptive terms, but by answer I mean like this number here, the number that's by itself. And that makes a lot more sense for the base, because that's the base of the exponent. It's what's to the power. So if we wanted to solve this one here, you could say, well, that's going to be the log of the answer, so the log of 350 divided by the log of 10. And on quizzes and tests, I see a lot of people punch all that in. And maybe I'll quick pull up my calculator and do that a second. So if I have log of 350, make sure you end your parentheses, divided by the log of 10. That's going to give me an answer of 2.544. So I'll write that real fast. So x then here equals 2.544. See if I rounded right. Yep, 2.544. The other thing that you can do actually that's even easier is going to be just take and punch this into your calculator. Because the base is 10, just like we were doing at the beginning of the lesson, you can just say, well, I'm going to do log of 350. And then hit enter, and you get the exact same answer. And the reason this gives you the exact same answer, just log of 350, gives you the same answer as log of 350 over log of 10, is remember a logarithm is really saying, well, what to what power equals what. So it's saying here, 10 to what power gives you 10. So in essence, the denominator of the fraction here is just a 1. So in summary, when you have these logarithm questions, you can go through and change it to an exponent if you're stuck. But if it's a common log, if the base is 10, or if nothing's written in, you know the base is 10, you could just do log of this number. So that's how your calculator's set. That's all about common logarithms.